So now that we're ready to model multiplication with Algeblocks, we need to figure out what model or what action multiplication is represented by in Algeblocks. If you remember back from Math 112, there were 6 models for multiplication. The first and the second model had to do with repeated addition and skip counting. The third and the fourth model had to do with arrays and area. And the fifth and the sixth had to do with multiplication tree and Cartesian product. So the Algeblocks model works specifically, is based on the array area model of multiplication. So where, if you remember, we say that when A times B, when we're multiplying A and B, then what we're looking at is we're looking at making a rectangle with those dimensions and finding the area. And that's the A times B. So what we're looking at is anytime we're multiplying two numbers, those are going to be our factors or our dimensions, and the product is going to be the area. So when we're looking at the multiplication, for example, of 3 times -2, then what we have is we have a factor, which is going to be one of our dimensions, and another factor, which is going to be the other dimension. And the product is going to be the area of the resulting rectangle. So let's see what this looks like on the Algeblocks. So for example, let's say we're still doing 3 times -2. And our factors are 3, the vertical factor is 3, and the horizontal factor is -2. So somewhere on the vertical factor, we're going to have to place 3. Well, our units are these. So there's 1, and there's 2, and there's 3. And on the horizontal factor, and that's in the positive direction, on the horizontal factor, I thought I had this figured out. We're going to have to put 2 in the negative direction, in the negative location. So let me just make sure that these are aligned nicely so that we can model. Oh, my goodness. So that we can model the rectangle that results from it. So there's my +3 and my -2. So notice that now we have the two dimensions, the two factors, and the rectangle that's resulting from it is this rectangle. So we need to fill that rectangle. What is the size of that rectangle? Well, in order to be able to figure out the rectangle of those dimensions, we need to make sure that all of our pieces line up. So let's say we'll line these up, and let's take another one and line that up, and let's grab another one, line that up, making sure that everything lines up. So the units that we're going to be using here are still our squares, and what we have once we're looking at the actual product is that we have the +3, the +3, times the -2, and the area is 6 in the negative. So what we have is that the product of 3 and -2 is -6. So let's go back to our picture and draw a representation of this. So when we were looking at 3, it's going to be 3 on the on the vertical and -2 on the horizontal, and the area is going to be the area of that rectangle that results from those two dimensions. And if we want to make sure that everything lines up, then the area here is going to be our product, and that is 6 in the negative. So this is going to be -6. All right, so let's try a couple more examples. I'll let you do B on your own, but let's try C. And I'm going to continue highlighting the factors. Whoops, let's write this out first. So -3 times -2. The two factors are -3 and -2. So -2 is one of the factors, and -3 is another factor. And let's see if we can draw this out. So it's -3 on the vertical, and it could be either horizontal or vertical, but let's make sure that we've identified which one. And -2 is on the horizontal. And what I need to do is I need to create a rectangle that is that dimension. So we're going to have this rectangle that we need to figure out the value of. So if everything is to line up, then the value of this rectangle is going to be 6, and it's on the positive. Okay, so that is multiplication being modeled with Algeblocks. So multiplication of two numbers is those two are factors, those two are dimensions, and the resulting product is the area. So let's see what this looks like now with as polynomials. So we have 3 times 2x, and we will again have the vertical factor and the horizontal factor. But now we have to model 2x on the horizontal factor. Let's go back to the Algeblocks and see what we can do with those. Okay, so it was 3 times 2x? Let's check. 3 times 2x. Okay, so we need to put 3 on the vertical factor and 2x on the horizontal factor. So let's zoom in here. So 3 on the vertical factor. There's 1. There's 2. Oops, and it does it. And there's 3. And 2x on the horizontal. Well, x, we can say that this rod is x. Oops, come on. Let's say that this rod is x, and we're going to put that in the factor track. And 2x means that it's 2 of those rods in the positive direction. So that's 3 times 2x. And if we look at the rectangle that creates, it's this rectangle here. So we're looking to fill that rectangle. Now, if we want to line up, for everything to line up, then this region here is going to be a yellow rod, right? You see that? So if we want to line up the yellow rod, and by the area, which is the dimensions are yellow rod by green square, it's going to be a yellow rod. There's another one. Oops. And, oh, come on. And there's another one. Okay. And the same thing on for the second yellow rod. Right there. Making sure everything lines up. So the two factors are 3 and 2x. And what's the area? The area is 6x in the positive. So let's go back to our drawing here. And if we want to write 3, so 3 by 2x, 2 rods, the area is going to be this area. That's going to be our product. So this will be our product. We need to figure out what that is. To do that, let's make sure everything lines up. And if we line everything up, then what we have is we have 3 times 2x, and these are 6x's, and they are positive, in the positive quadrant. So what I'd like you to do is do number E on your own, and let me know if you have any questions, but let's try with F. 2k times 2k minus 3. So if we write this out, then we will have a vertical factor, which is 2k, and a horizontal factor, which is 2k minus 3. So let's go back to Algeblocks and see if we can model this. 2k times 2k minus 3. So 2k times 2k minus 3. So to do the vertical factor with 2k, let's say the k is the yellow rod this time. Okay, so 2k, 2k. That's okay, that's 2 k's on the vertical. Now on the horizontal, we need to talk about 2k minus 3. We need to model 2k minus 3. So there's the 2k, but where's the minus 3? Well, the whole horizontal factor should be representing 2k minus 3, and the 2k was positive, but the 3 is negative, so the 3 can go on the, would have to go on the negative side, oops, of the, oh, come on, of the factor track. Okay. All right, so where's the rectangle here? Do you see that the horizontal dimension goes from here to here, and the vertical dimension goes from the axis here to up to the top of the yellow? So if we wanted to draw a rectangle with those dimensions, the rectangle would actually be on two sides of the 4 quadrants. So let's see what we would need to fill that space with. Well, here we have a situation where we had x by an x, and to fill that, I think it would make sense to try and put x or k squared in that space. And that way, everything, all the pieces will line up very nicely. Okay. Now, what would go on the left? Well, on the left, we have k by 1s. So if we wanted to line everything up, we would be needing to use these rods. It's much easier when you actually have the Algeblocks in front of you to play with. So if you have an opportunity, if you have a choice, use the visual, use the manipulative. But you see here that we have the area is in 2 parts of the quadrant, and some of 2 parts of the 4 quadrants, and some of the area will be positive and the rest will be negative. So let's redraw this on our representation here. So we had 2k, oops, 2k, that's our 2k, times 2k minus 3. And our rectangle that we are going to be looking at is this rectangle. So that's what we're going to be looking at for the area. This space and that space. And one of those spaces is positive, the other space is negative. So if we're going to make everything line up to see what the area is going to be, we're going to have 4 k squareds here, and we're going to have 6 k's there. So the 4 k squareds are positive, and the 6 k's are negative, minus 6k. Now you can see that this is visually, it makes sense that those are the 2 areas. The one area, the one on the right, comes from the 2k times the 2k. right? So this came from the 2k times 2k. And this area came from the 2k times -3. So do you see, although we're not going to be talking about distributive property here, but do you see where the distributive property is starting to appear? Right? There are two parts to this final area. One of the parts is a result of that 2k by 2k rectangle, and the other part is the result of the 2k by -3 rectangle. So it's very interesting, and even though we're not going to, with Algeblocks, we don't have to introduce the distributive property. The kids are going to see it, and they're going to actually notice it and generalize it and say, hey, is this always going to be the case? So I'll let you work on G on your own. And again, remember to ask me questions if you get stuck. But let's look at H. So with H, we have two factors. And let's say that we're going to, excuse me, have the 2c plus 1 on the vertical and c plus 2 on the horizontal. And I'm going to stick to drawing this. I think we've had a lot of practice with the Algeblocks themselves, the physical Algeblocks. So let's say that this is 2c plus 1. Right, so that factor is 2c plus 1. So 1, c, and c. Now this factor on the horizontal is going to be c plus 2. C plus 2. C plus 2. So the rectangle that we have is actually going to be all on the positive side. So the area is actually going to be all positive. So this is what our product is going to be this area. So let's see, if we were to make sure that everything lines up, let's see what we have for the product. Do you see c squareds in here? So we have 2c squared. Now, do you see c's in here? So that's 4c. Oh, and there's another c in there, plus c plus 2. Right. So we could, at this point, we have c's in a couple of different places, so we could simplify them visually because the c's are, we can write them as 5 c's altogether. So we have the expression for the area. Now, where did this happen? Where did this come from? So the c squared came from 2c by c. So this came from 2c times c. This c came from 1 times c. These came from 2c by 1. Oh, by 2. 2c by 2. And this came from 1 by 2. So do you see the distributive property showing up in there? We're never going to say FOIL. FOIL is an acronym. It's a leap of faith. We all memorized it. Very few of us actually understand where it comes from. So really what we want to do is we want to make sure that the whatever these procedures are that we're using actually make visual sense. So when I was teaching the first time, I had my department chair came in for an observation, and I was teaching FOIL, and I thought I did really well. And then she calls me into the office and she says, please make sure you don't swear in class. And I was horrified. I didn't know what she meant when she said I was swearing in class. She said, well, you were using the F word. I said, what do you mean? I never used the F word. She goes, well, it's a 4-letter word starting with the letter F, FOIL, and we don't swear in class. So, even though it was a funny comment, the sentiment is quite clear. FOIL is just a mnemonic. It's not connected to real mathematics. It's just a trick, and it's a leap of faith at best. So what we want to do is we want to make sure that anytime the kids are actually doing the multiplication of polynomials, that they are visualizing it and they have a visual model that they can rely on. So I have a whole bunch of examples on page 18 that I'd like you to work through. Now I'm going to do two of them, so that I'm going to do J and L. And then if you have any questions on I and K, you can make sure to ask me and I'll flesh those out as well. So let's look at the vertical factor and the horizontal factor. And let's model those. So we have minus P, let's say that's P, and minus 4. So all of that on the vertical factor is going to be on the negative. All on the vertical factor is going to be on the negative. On the horizontal factor, we also have everything in the negative, minus 2p minus 1. So our area is going to be down here. And let's just outline that rectangle. That's going to be the area that we're looking for. So if we want to line everything up nicely, pardon my curvy lines, okay, what we see is a couple of regions. So we see, and let me actually highlight those regions. So I'm going to get rid of that highlight and I'm going to highlight again. So let's look at this region. Where does that region come from? Do you see that that is the positive 2p squared? Right? That's 2p squared. That comes from the minus p times the minus 2p. There's another region. There is this region. And that region is going to be the plus, oh my goodness, this got erased as well, plus 4. Plus 4. All right, and then there are two other regions, and those regions are this one. Let me just make sure that I don't run over here, and this one. All right, so though, and I'm just going to do that in a slightly different blue. Still blue, slightly different blue. So there's a region of P and there's a region of 8P. So there are 4 regions. There's the square region, the ones region, and then 2 regions that are P, that are linear rods. So we can simplify that. We can combine the 2 regions that are rods and come up with a simplified product. Now let's look at this one. This is squared. Now we can rewrite the square as something times itself. And we have a vertical and a horizontal factor. And they happen to be the same. That's why we say squared, and that's why we're actually expecting the area to be a square. So let's say minus 2c minus 1 minus 2c minus 1. And the area that we're going to be looking at is this. And if we make sure everything lines up nicely, we have something like that. Now let's look at the regions here. We have this region of squares. We have a region of ones. We have a region of rods. And we have a second region of rods. So let's write this out now, and it's all in the positive. So we have 4c squareds. We have 2 c's in the light blue, 2 c's in the dark blue, and plus 1. So if we wanted to simplify this, there'd be 4 c's altogether. 2 of them in the light blue and 2 of them in the dark blue. So that would be the simplified region, the simplified product. So practice as much as you can. I will also post some practice exercises, just like I did with the first example. And then Let me know if you have any questions about the other ones that I haven't solved.